Alright, let's talk about the motor principle. So we have covered already Orsted's discovery here that the current in a wire could cause a compass needle to move. And then Faraday heard this and he said, well, if a wire can get a magnet to move, can a magnet get a wire to move? And yes, he was successful. So let's look at these four diagrams here. First one, it's a horseshoe magnet. The force lines run from north to south. Pretty straightforward. Here I've got a conductor. It is coming, current is coming out of the page. Yes, if you get your right hand out, and you, when we talked about this guy, the magnetic fields would be going in a counterclockwise fashion because your thumb would be pointing at you because it's coming out of the page, and your fingers would be curling around like this. Now let's put this conductor inside of this magnet here. And you'll notice here that on this side all the arrows are pointing down, yes, and I'm getting a build-up of these force lines. And on this side some are pointing up, like this one and this one, but these ones are pointing down. So over here I'm getting cancellation, yes. On this side build-up, over here cancellation, and what that means is that when I think about this conductor and the forces that are acting on it, building up, weak, building up, weak, boom, this sucker moves this way. The results of this experiment can be summed up by the motor principle, which states that when a current-carrying conductor is located in an external magnetic field perpendicular to the conductor experiences a force perpendicular to itself and to the magnetic field. Blah, blah, blah. How are we going to remember all these words? Well, we're going to use another right-hand rule. So if you get out your right hand and kind of put it in the picture here, just like in the picture, your thumb in this case is current, your fingers point in the direction of the magnetic field, and the force comes up out of the palm of your hand. Okay? Force from palm. Okay? So here's our third right hand rule to determine the force on a conductor in a magnetic field. Now, if I wanted this force to be bigger, what could I do? I could have a stronger magnetic field. Yes? I could have more current. Would give me a bigger force too. Just looking at the factors. Oops. Just looking at the factors here in this diagram. And the other thing is this wire. I could have more wire in the field. Yes? And instead of just having a single wire in it, what they engineers, scientists learned is, hey, why don't we put like a loop of wire in there, and then we get all sorts of wire in a very small distance this way, right? Instead of just having this much wire in it, if I loop it, I can get all sorts of wire in here. So more wire in the field, preferably in loops, more current and a stronger field. All of these things would give me more force.